Now, we will go to take up one more problem, problem number 40. A member, capital ABCD, is subjected to a point loads as shown in the figure. Calculate number 1, force P necessary for equilibrium. So that is force P and also total elongation of the ball. Take E equals 210 giganewton per meter square. So here you have 3 stepped bars having area of cross section of 600 mm square between AB and 2400 mm square between BC and 1200 mm square between CD. So AB has got a length of 800, BC has got a length of 1000 and CD has got a length of 1500. In the member AB, on the left hand side you have 50 kilonewton and P on the other side, and between 2400 mm square, that is BC member, you have P on the left hand side and 500 on the right hand side. Between 1200 mm square, that is CD, we are going to have 500 kilonewton and this is 200 kilonewton. Now first we need to find what is the force P necessary for equilibrium. The condition says for the equilibrium condition, the load which is acting on the left hand side should be equal to the load should act on the right hand side. So the left hand side loads are 50 kilonewton plus 500 kilonewton, which will be equal to the right hand side, which is equal to P and plus 200. So take 200 to the left hand side, that means 550 minus 200 will going to give you 350. So P will be equal to 350 kilonewton. Now we will going to find out the equilibrium condition for the individual segment. So first we are going to consider for the segment AB. When you are considering for the segment AB, on the left hand side you are going to have only 50 kilonewton which is acting toward the left side, so it is positive because it is tensile. On the right hand side we have 350 kilonewton acting towards right, 500 kilonewton acting towards left and 200 kilonewton acting towards the right side. On the right hand side, if the load acting towards the right side is tensile, so that is positive, and the load acting towards the left side, which is negative because it is compressive. So then therefore you are going to have 350 minus 500 plus 200, so you are going to get 50 kilonewton to the right. So therefore the first member AB, now it is in equilibrium condition, having an area of cross section of 600 mm square of length of 800 mm. So you will going to have 50 kilonewton. Now when you are considering for the second segment between B and C, on the left end you have 50 kilonewton which is acting towards the left side and 350 towards the right. So on this you are going to have plus 50 minus 350 which is equal to minus 300 kilonewton. On the right hand side you have 500 kilonewton which is acting towards the left and 200 kilonewton which is acting towards the right. By sign convention, acting toward the left is negative and acting toward the right is positive because of compressive and tensile respectively. So that is minus 500 plus 200 will be equal to minus 300 kilonewton. On the left hand side is also minus 300, on the right hand side is also minus 300. Therefore, the member is in equilibrium condition. So that means you are going to have compressive load. So that is 300 kilonewton. On the left hand side and right hand side you have 300. So now the body, which is BC, is in equilibrium condition, having a length of 1000 mm and 2400 mm square as the area of cross section. Now when you are considering for the segment CD, on the right hand side of the segment, which is CD as 200 kilonewton. So what are all the forces which is coming on the left hand side? The left hand side you have 50 kilonewton acting towards the left, 350 towards the right and 500 towards the left. So the left hand, the low forces which is acting towards the left side is positive. So plus 50 minus 350 plus 500 will be equal to 200 kilonewton which is positive. Therefore the load acting towards the left side will be positive there, which is 200 kilonewton. On the right hand side, and the load is acting toward the right side, you have only one load which is 200 kilonewton. So therefore segment CD now is in equilibrium condition, having a length of 1000 to 1500 and the area of cross section as 1200 mm square. Now we will going to take up the force P. The force P for equilibrium of the bar, loads acting towards the right side must be equal to the load acting towards the left side. So P plus 200 will be equal to 50 plus 500. So P is equal to 350 kilonewton, which we are already explained. Now we want to have the total elongation of the bar. The total elongation of the bar, which is equal to delta L, will be equal to elongation of the segment AB plus contraction, that is minus contraction of the segment BC plus elongation of the segment CD. So delta L will be equal to P into L by A into E of AB minus P into L by A into E of BC plus P into L by A into E of CD. So delta L will be equal to, so now you substitute the values P, which is 50 into 10 to the power of 3 into 800 divided by 600 into 210 into 10 to the power of 3 minus 300 into 10 to the power of 3 into 10 to the power of 3, because the length of the segment is 1000 divided by 2400 into Young's modulus is 210 into 10 to the power of 3 plus P, that is 200 into 10 to the power of 3 into 1500 divided by 1200 into 210 into 10 to the power of 3. So on simplification, you will going to get the first one 0.3175 minus 0.5952 plus 1.905, that is equal to 0.9128 mm. So this is how you will be able to solve this problem. Then we have the problem number 41. The two vertical rods, one of steel and the other of copper, are each rigidly fixed at the top and 500 mm apart. Diameters and length of each rod are 20 mm and 4 meters respectively. A crossbar is fixed to the rods at the lower ends, carries a load of 5 kN such that the crossbar remains horizontal even after loading. Find the stress in each rod and the position of the load on the bar. ES will be equal to 2 into 10 to the power of 5 Newton per mm square, and Young's modulus of copper will be equal to 1 into 10 to the power of 5 Newton per mm square. So here you have a steel bar of diameter 20 and the copper bar of diameter 20 having 500 mm apart. So these two, copper bar and the steel bar, of 500 mm apart. The diameter, the length of steel, which is 220 mm diameter and 400 mm length, and the diameter of copper. And here he has given the diameter of copper also, which is equal to 20 mm. And the bar has got 4 meter length, so 4000 mm. And a crossbar is fixed to the rods at the lower ends, carries a 5 kN, such that the crossbar remains horizontal even after loading. Find the stress in each rod and the position of the load at what distance. So we are going to assume the distance as x. Now when you want to do stress in each rod, so let PS and PC be the tensions in the steel and the copper bar. From the equilibrium condition, PS plus PC will be equal to 5 kN, that is 5000. So that is, what is PS? PS is nothing but sigma S into AS plus sigma C into AC is equal to 5000. So sigma S plus sigma C will be equal to 15.9155. So as the crossbar remains horizontal, the deflection of the steel and the copper are equal. So that means delta S will be equal to delta C, which is PS into LS by AS into ES is equal to PC into LC by AC into EC. So what is PS by AS, which is equal to sigma S by ES, then is equal to sigma C into EC, because the length of the steel bar is equal to the length of the copper bar. So similarly, substitute the values of Young's modulus of steel and copper. Sigma S by 2 into 10 to the power of 5 will be equal to sigma C by 1 into 10 to the power of 5. So sigma S will be equal to 2 times sigma C. So what will going to be the value? So when you say sigma S is equal to 2 times sigma C, you substitute this in 2 times sigma C plus sigma C equals 5000. So that is 15.9155. So stress in the copper rod, so that is 5.305 Newton per mm square. So 3 sigma C is equal to 15.9155. Therefore, stress in the copper rod, which is sigma C, will be equal to 5.305 Newton per mm square. So what is the stress in the steel rod? Stress in the steel rod will be equal to 2 sigma C. That is, substitute the value of 2 into 5.305. Therefore, it will be equal to 10.61 Newton per mm square. What will going to be the position of the load? The position of the load, tension in the steel rod is PS, which is equal to sigma S into AS, which is equal to 10.61 into pi by 4 into 20 square, which will be equal to 3333.23 Newton. Tension in the copper rod, which is PC, is sigma C into AC. Sigma C, 5.305 into pi by 4 into 20 square again, which is equal to 1666.615 Newton. Taking the moments about the copper bar. So what is the copper bar? That is 5000 into X will be equal to PS into 5000. So here, how do I know that? The position which will be able to calculate by using this here. Moment about the copper bar will be equal to 5000 into X will be equal to, so the tension in the steel rod PS into 500. So that is how you will be able to get this. So once you get this, here 5000 into X will be equal to PS into 500. So you know the value of PS. 5000 into X will be equal to, substitute the value of PS as 3333.23 into 500. Therefore, the value of X will be equal to 333.32 meter mm. So therefore, the position of the load is 333.32 mm from the copper bar. So this is how you will be able to solve this problem. Thank you.